Hello and welcome back to the channel. It's me, Mark, and today we're going to have a look at setting out a distribution board. And this is the Proteus BX. We're going to tie it in with the mains isolator we've got down here. So we need to be setting out our tails leading into the board and the main switch in alignment to try and get that nice. And then also our final circuits are going to drop into the top of this board here. Now we're not going to use some trunking and bring those cables in directly to the board itself, and that's really just to demonstrate the plate on the top and how we can mark that out, put some holes in it and set up some steel wire armour cables coming in. If this was out on site, you may be using trunking and then glanding into that. There are loads of different options, but it's just to show the flexibility in this board and how you might approach bringing cables into and out of a distribution board for those of you who are learners and in training. So hopefully it's of some use. I have got a Starrett holesaw set to demonstrate. This is a new one. I bought it. It's not been gifted, paid, promoted or otherwise. It's just one that I thought was worth giving a shot because it claims to be a lot faster than the traditional bi-metal holesaw sets we might use. And I've got some of those from Armeg and a Starrett set as well, so we'll have a play around and see which ones can actually cut the holes first. But these are the tungsten carbide tips. They claim to be faster and to last longer, and if you're cutting through thicker metals, for example, these are going to come into their own, because the bi-metal ones do tend to get a bit hot a bit quick if you're going through anything other than the metal on your trunking and distribution boards. So we're going to have a look at that. But yeah, we'll get straight to it. We'll mark all this up, get some tails in the board, and see how we go from there, and we'll have a look at the different cut sets and see how they perform. We are also going to put a little single phase Proteus board just to the side of here, and again this is just a demonstration for people to come into the academy here and copy, see how they can achieve the same result, something to work from visually rather than just on a bit of paper. A massive thanks to Proteus, because this equipment is stuff that they have provided to us here to make use of for those coming in to try and build on their skills and knowledge outside of the day job and regular training spaces. So thank you, Team Proteus, for that one. Without further ado, let's get straight on with it. So setting out is so important, making sure that your enclosures are level. As you can see, we've got here, we know we're bang on square and level with the actual distribution board, and then I pinged a laser line straight down the middle of this distribution board here, through the middle of the main switch at the bottom as well, and that's so our tails cables can look nice and come straight up into this distribution board here. And we've got a mark for the trays and steel wire armors coming down centrally on this board as well. They may all end up fanning out if you've got a few going in here. Obviously, as I said at the start of this video, you're most likely to be using trunking if you've got a lot of cables coming into a distribution board. But for a small little one like this, you could be doing some EV charge points, going straight out in your steel wire armors and bringing them down on some trays straight into the board is a great fast way to enable connection into the distribution board. But yeah, setting out, really important. So we've now got our centres marked here. I'm going to pop some marks on the wall, so we've got that done. Pop some marks on the underside of this sheet here, so we can drill out for our entry for the tails. And then we can pop some marks in the top for entry for our outgoing circuits as well. So I'll get on with that and we'll jump back and have a look where we're at in just a minute. Okay, so first up is the setting out, and usually I would cover this in masking tape, so we can mark it all out on there and then drill it. But because we're demonstrating the actual cutting of the drill, I wanted to see some of the metal filings that may be dug out by the blades. So I'm just going to mark them freestyle straight onto the metal itself. I've got a few different varieties of glands here just to show the different ways you might approach setting out. So we've got our tails gland here, it's a 40mm metal variety. You could use a plastic one, you could use a bush and coupler, you could be going into trunking. There's loads of different methods that you can take to bring your tails main cables in. We're using this in this case. We've then got some storm glands from SWA, so these are steel wire armors, and we've got the piranha style nuts on the back of those, and then we've got some traditional weatherproof glands over here with the banjos as well. So when you're setting out, you want to be checking for the space in the top of your board. Don't make anything more difficult than you need to in terms of bringing your cable in, and taking account of all the circuits that you're bringing in. So in this case, we're going to say we've got 4 cables coming in the top. These are 25s, so 25 mils, and these are 20s, so we can set those out across the top. And then in the bottom, we want to bring the tails gland, as we know, right in the centre, because we've already laser leveled that through the board. So the first thing we need to do is see how big this actual steel plates are, so we can set to marking them out. And these are 85mm, so that for dead centre we want to be 42ish mil, and I've marked that in by eye with that black dot just underneath freestyle. I was pretty close. So that's our centre point here, is centre. So this is where we need to make our hole for the 40mm tails gland. This is our bottom plate. And then on the top, you can see here, it's the inner face, the outer face, you can see where the screws have been mounted. We already know again that our centre mark is going to be that 42.5mm. However, we're setting these out a little bit different, so best way to do it, I always find, is to lay the glands on the top. So we'll do that with these, and again we're going to try and bring the tray down the middle. So I've got this one here with its banjo on, and I often find it's easier to just sort of freehand them on for now, just to try and see where they're going to live, and then you can make your mind up on how you want to set them out. So you see, if we overlap those banjos, we can use just the one nut, and you need to leave enough space between them so you can get the nuts on from the underside and get your spanners in to tighten them. Sometimes if you go too tight like this, once you come to put the nuts on the underside, you've got absolutely no chance. So don't be too tight on your spacing, give yourself a bit. And then the same with the piranha nuts. You see these are quite bulky, and once you start rotating these inside, they can soon hit onto each other and stop you tightening them. So again, set out some reasonable spacing. If we pop this little measure on, you can see roughly what we need. So they're about 150mm-ish at the minute as they are set out. So we've got a 150mm tray coming down the wall, and they will fan out on the plate as they exit that tray as well. So if we find the centre point now, and we can start trying to set these out, I've roughly got the centres on those at about 40mm. So you can see what I've done here is get this marked. So this is a centre line, again at the 42.5mm, I think it was, wasn't it? Yeah. So we've got that centre line marked across here, we've got a centre line marked here, and then I've marked on these outer edges of where our glands are going to live between. So we can start to now make our marks for our centre holes for the cuts we need to make for these. Now we've said they're going to roughly have 40mm spacing between each other, and the one thing we didn't look at was the spacing between the piranha nuts and the actual normal steel wire armour bands. So I'm just going to pop them back on and we'll have a little look at that and see where we're sat here. So now I've marked the width of the trunking onto this top plate, and I've set the glands onto here. We can start to get our marks for the centres of these holes. So I've popped my set square back on so I can see the outer edge of the trunking. So we've got it on 0 over this end and 150 at this end, and I can now take a measurement for the centre of all these holes. So we've got 15mm on this first one, we've got 60mm on this second one, or 100mm on the third, and this final one, because these are a little bit smaller, is 135mm. So now I've got those measurements, I can take these glands off and mark those centre lines ready for drilling. So being careful to set the square in the right position, we need to mark 15mm, we need to mark 60mm, 100 and 135. And you can then see your spacings on this more visually. So this line here is our outer edge, this is an outer edge, and then these are our holes all the way along. Now when you look at this, obviously when you're on your masking tape, you can think actually I'm going to shift that a little bit further that way or that way. Whilst you've got it all on there to mark out, it's worthwhile taking your time, because when it's on the wall it becomes more of a visual thing, and if you've got things over to one side, you know, you're going to start cramping yourself for room. And equally in setting up in this way, if anybody ever wanted to bring a cable in at either edge, they can do so. I mean, you could have set your cables coming in at this side of the board or that side of the board. I've just gone for the middle in this case, and now that's all marked out, we can set to with some drilling. So these are both fresh new sets for use here at Apprentice 121. I've got a set of these Starrett ones in the van that are in much worse condition, well used. I've had them a long time, they're still super sharp. These are your bimetal hole saws that do last very, very well. I've never had a set of these before. These are a brand new one on me, but again, we've got them to use here. They're supposed to be faster, sharper cutting, and all that good stuff. So we're going to try each of these on each side. We'll do a 25 and a 20mm hole with this, and a 25 and a 20mm hole with this, and see how they perform in terms of cutting those holes. And then equally, we can have a little look at the 40mm one in the tungsten and see how that cuts the bottom plate as well. So I'm going to get these bits into a drill now and we'll give them a little go. Okay, so let's try the bimetal one first. I'm going to use the same drill on both, so this is just basic DeWalt combi with a 3 amp hour XR lithium ion battery. It's not one of the fancy ones we would usually use, but we'll see how it does. As long as it's the same drill, we should be laughing. So we need to get on our centre line first. So I just super quick cut all those holes. You see this 40mm ones come up really nice and smooth on the inside. The tungsten carbide blades are definitely faster. They do give a nicer cut through the metal as well, but they've all come up pretty clean. There's no real downside to using the bimetal saws other than wearing them out slightly faster. These will last longer is the claim. We'll put that to the test here because these will be used a lot. And yeah, happy with that. I've got my holes in the right place. Got our 225s, the 220s and the 40. I did quickly make use of this Milwaukee stack as a base plate. Usually you'd have a workbench with clamps to hold your material in place. I've shown that lots on the channel before, but it's in use by somebody else at the moment, so I've been making do with this here on this little video. They've come up good. We can get them mounted back into the board now, pop our glands in and see how all of that comes together. So a little tip when you are bush and coupling your distribution boards, consumer units together, as you can see we're trying to here, pop the little mark on the front. Again, I've just used red marker. I'd normally use a pencil, but you get a bit of visual idea of it and where I'd like the hole to be on each side. And then we've got a mark on these, so if we go through at the same distance off the back and we set a square along that line, they should line up nicely when we come to put them together. So you can see I'm using 2 lock rings as a spacer between the 2 boards, and that's so the lids can go on. If you go too tight with your spacing, when you come to try and fasten your lids on the front of the boards, they'll catch on each other. So just to give a little bit of a gap between the 2. Just got a little brass nut and bolt. I think they're on that shelf in there. Okay, so brass nuts, bolts and washers are always the go-to for the banjos, always nuts out. So pop this in just loose fit for now. So it's a bit long for what we need, but we can always cut that down when we get to the stage of wiring this up. I'm just putting these glands in, ready to go. We'll move down now and wire the tails in, and I think we're going to leave it there on that video. We'll have a look through where we've got to after that stage. So here you can see how we've got it set up. I've not terminated the neutral yet, because we're going to wait to dress all these final circuits in. On another video, we'll bring some trunking down, bring all these cables down, dress them away into the board. We've got the neutral there ready to be lugged up into these bars. Got our main switch. Again, trying to keep these as tidily as we can possibly. You can bring little loops in if you want to leave a bit of excess on your tails. It's totally your choice as an installer. In this case here, I've had quite an easy setup, so I've just brought them in nice and straight, nice and smooth. This gland is largely full. I can just nip that up now, and that'll tighten down on there to give us the IP rating we need on the bottom. There's no one sticking their finger in there. The tails are nicely protected. These metal glands have a rubber washer inside, so they're coming through super duper nice. They're not caught on anything. Our outer sheath is still in place and they're secured. These isolators external to the board, absolutely golden if you've got a few bits in your three-phase install. So you're talking small shops, office blocks and such that might be on 100 amp supplies. These isolators absolutely brilliant for that purpose. Obviously, as you go up in size, you're going to need some bigger switchgear for your main isolation, but this is absolutely ideal. It is rated up to, if I put my glasses on, so that's 100 amps, and these are 60947-3s, and again colour coded. So you've got your L1, 2, 3, and your neutral. Well, colour coded in the sense you can see between line and neutral. Obviously, the colours for your actual phases, I've not marked these up, but on the bottom of this main switch, I'll bring you in closer in a minute and show you. There is some coloured markings across the phases, so we can see we've got our brown, black and grey, which indicate into the bottom of this main switch the corresponding terminals for our L1, L2 and L3. These glands are just loose fit in the top, see I've not fastened them down. The SWA piranha nuts have little locking pins in. Start taking all that out, stuff will go missing, so I've left them in there, just loosely fastened them on, and for the next person coming along to work on this, they can do so quite easily. We'll zoom in really close, go through it all, we'll put the lid on and then close this video up. We'll start on the underside. You can see all of the glands coming through there, and as I mentioned, I've left those screws and locking pins in those piranha nuts. Got our banjos through the head of the bolt for our banjo earth bond, if you like, fly lead. You can see that's up the back there as well, with the nut sticking out ready to go. All neat and tidy along the top there, as we would want. We've got our spacing on the board, so you can see in there we've got our 2 lock rings, and then a lock ring either side, and again these need tightening up, but that's giving us a route through between our single phase and 3-phase board, again without using any trunking. Traditionally on a bigger install you're going to have trunking around your boards. This is just for a small simple installation. We've then got our main switch down here, and as I said, colour coded with brown and blue, 100 amp rated, and the tails running nice and neat up through this 40mm gland on the bottom there. You see set in the middle of those 2 screws, it just fits nice, which is what we want. And then coming out the top, these are nicely locked in now, straight up and away into the bottom of that main switch. And as I mentioned, they're colour coded, so you've got your brown, black and grey. We've got some RCBOs in here prepped already. We've got our neutral tail ready to wire into the neutral bars. And yeah, we're all good to go now on that as a second fix. Inside this board, we've got our Proteus SPD, which mounts directly on the bus bar, for those of you who haven't seen that. And you just need to wire in your neutral and your earth, no overcurrent protection needed, on up to 100 amp supply. So that's a good win. And these are all ready now to be dressed away with some final circuits, which we will come to in the next part of this video. But that's just a basic set out of a 3-phase board leading onto a single phase board with your gland plates marked and drilled, and I think that's come up pretty good. So I've decided to leave the covers off because when we come to the next stage of this install, we're going to need them open anyway. So this is it now. I've put the lids up there with the screws that secure the front on, so it's all together. As I said, these glands are just loose fit for the minute. They're going to be properly terminated when we get to that next stage. And normally you would have some trunking around your distribution boards on a 3-phase setup to wire all your final circuits into. But as I said, this is all trying to help set things out to trainees and apprentices so they can see where stuff is going and visualise it. It's kind of designed for those who are coming into industry in sort of years 1, 2 and possibly even 3 to really understand where the cables are coming from, where they go to and how we go about wiring them up. Out on site, this would have generally had some trunking around it for glanding off those steel wire armours, also bringing our main supply through as well. But for a small simple setup you don't always need to. There's only 4 final circuits coming out of here and we've got our main tail straight in the bottom. It's perfectly acceptable to run out in some tray and take your circuits away in the steel wire armour off to wherever they need to be. And as I said, we've just bolted on this single phase board. Again, really to try and visualise to learners and trainees the difference between single and three phase and how we go about wiring those final circuits. Kindly, Proteus have given us these, as I said at the start of the video. Everything else I have bought to use here at Apprentice 1-to-1 Academy, so the Starrett sets, the Klein level, the SWA glands, all the other bits and pieces that you've seen in this video, I have paid for. If you are in a position to help out your local training providers, please do so. I know firsthand here, obviously these top plates on these distribution boards are now drilled. These things are taken apart and put together so much by people going through training that even basics like that can be absolutely essential. So when you're out on site, fitting in your trunking and you're maybe taking these out to fit some paxel in between, don't just throw them away, collect them up together and maybe drop them into your local college or training provider, because the chances are they will be really grateful of it. Equally, any components you are removing from jobs, if you're taking out circuit breakers, RCBOs, even distribution boards that are still in workable condition, get them dropped down there if you can, switches, sockets, anything and everything. The training sector is in dire need of support in terms of materials and equipment, so if you are able to help, even if it's used stuff, please do so. Thank you to those who help us out here at the Academy. We were really well stocked here now. I've been buying lots of bits and pieces for a long time now, and the kindness of others donating things like EV chargers, battery storage systems, and stuff like that that we can use for people to come in and use has been absolutely exceptional, but we don't need anything else. I'm taking stuff now on a monthly basis into colleges and training providers of stuff that we are sent and things that I've bought to try and help out in the training environment. It's a massive growth time for us as electricians, and the training sector is going to be under enormous pressure to try and help bridge that gap between the volume of trained and qualified people we're going to need and those that we actually have. So if you are able to help, please do think about that in the future. If you've got any questions in and around this content, please do drop them in below. Bear in mind, if you're thinking this isn't how you would have set it up, it is a training example for people to visualize, as I said, but do drop your tips in below how you'd set this out with trunking. You never know who you could be helping who's watching along with these videos on their learning journey. I can take any constructive criticism as well, and perhaps some of your tips will help me on my future installs. Thank you all very much for watching, and I will see you on the next one.